to move to something called dimensional analysis. All right, so we're going to move to dimensional analysis. Now, dimensional analysis is a technique that is used for conversions. So it is used for conversions and certain types of calculations. Whoops, that's a C. All right, so dimensional analysis is used for certain types of conversions and calculations, and it is based on the idea that the units of a number actually travel with it in equations or in calculations, and your final units actually come from the mathematical process that you moved through the whole way. Let's say that you want to do a calculation about speed. Speed is equal to distance divided by time. Now, most of the time, let's just say, for example, though, that I wanted to, that I was going to cover 100 miles in, well, I'll tell you what, let's say 140 miles in 2 hours. Okay, so 140 miles in 2 hours. And what you can see is that if I take, oh look, there's the bell. I'm just going to let that ring, just going to embrace it, enjoy it. All right, it's over. So I'm going to take that 140 miles, and we can see that the numbers 140 divided by 2 are going to reduce to 140 divided by 2 to 70. Now here, though, I have some units, and they don't reduce. Miles divided by hours, because remember that fraction bar actually means divide. Okay, miles divided by hours does not reduce to some other, I can't just cross off some of the common letters, like, oh, the S goes what? Nope, can't do that. It's miles and hours. And so we just keep both, and we express it as miles per hour. And so you actually keep both units, and you even keep the dividing or the per line. And so that's what happens there. The number reduces, the units don't reduce, and so you have that for both of them. All right? The key to dimensional analysis is we can actually set things up in a way that they will reduce. All right? So let's look at what we did a minute ago when I had 1,500 meters, and I want to convert to kilometers. Ooh, that's a terrible line. Sorry about that. And I want to convert that to kilometers. What I'm going to do is I'm going to put in here a conversion factor. Now let me just come up here and mention something. You know that if I take any value, like let's say that I have a value of x in algebra, and I multiply it by 1. Okay, that then is technically 1x, but we actually leave the 1 out and just express it as x. What I want you to remember is that if you multiply something by 1, you're not changing its value. And so it is always legitimate to multiply something by 1 without changing its value. And something that we do, in fact, is often we'll use that to change denominators in fractions. So if I have 3/5, but I am going to add that to, say, 4/10. Well, I can't just add those directly because they're not common denominators, and so I need to make a change. And what I'm going to do is I'm going to change this. So I'm going to take 3/5, and I'm going to multiply it by 2/2. Because 5 times 2 will then get me to 10, which will be my common denominator. And 3 times 2, of course, will be 6. And here's what I want you to know. You know and are aware that 6/10 is equivalent to 3/5. And the reason that those are equivalent is because I transitioned from 3/5 to 6/10 by multiplying by 1. you see that is still multiplying by 1. It's 2 over 2. And so it is legitimate if you have equivalent values to multiply, and it's as if you're multiplying by 1. You're not changing the value of the item. So I'm going to take 1,500 meters. Okay, so Mr. Willis, what does that review of my 7th grade fractions and Algebra 1 have to do with anything? I'm so glad you asked. All right, so we're going to look here at, I'm going to take 1,500 meters, and you remember that 1 kilometer was actually equivalent to 1,000 meters. Okay, and so what I'm going to do is I'm going to set this up. Ah, yes, there's that fabulous bell again. Love it. Okay, so we've got our 1 kilometer and our 1,000 meters. And I'm going to set this up just like a multiplication and division problem. I will take 1,500 meters and multiply by 1 kilometer. Well, 1,500 times 1 will give me 1,500. And here, I don't have anything here. There's an implied 1, because remember, you can always put something over 1. So if you want a placeholder, you can put a 1 there. 1 times 1,000 meters is going to equal 1,000. And I still have my dividing line. Okay, so I'm getting 1,500 divided by 1,000. Here's what I want you to see. My meters are in both the numerator and the denominator, and so they will cancel out, and I'll be left with only kilometers. So I have 1,500 divided by 1,000. Oh, well, 1,500 divided by 1,000 is 1.5, and I have kilometers as my remaining unit. So that will then equal 1.5 kilometers. Okay? Realize I wrote that kind of small and off to the side, but just trust me, it says 1.5 kilometers. And that's what you get when you do the division and cancel out the units that are in the numerator and the denominator. All right? So let's do another example of that. We're going to, let's see. I'm gonna pick up a few of these things here. And, oh my goodness, all right. There we go, great. All right, so we're going to do another, now if I said that I wanted to convert 5 minutes into seconds. Okay. Well, you say, Mr. Willis, we don't need to convert. I'm very good at math. 5 times 60 is 300, and so it's just going to be 300 seconds. And you're correct. Congratulations on your math genius. Well done. All right, and that's because you have memorized the fact that 1 minute is equal to 60 seconds. Now let me show you what that would look like as dimensional analysis, just to use our example. Okay. Okay, and so we've got 5 minutes, and then I made that line a lot longer than it needed to be. Sorry about that. 1 minute is equal to 60 seconds. Mr. Willis, how do you know whether to put the 1 minute on the bottom or the 60 seconds on the bottom? You always want to put it so that whatever you're trying to get rid of will cancel out. And so I want to set it where my minutes will divide away, and then I'm going to have 5 times 60, and that, of course, is 300. The only remaining word, the only remaining unit is seconds, and so that's how that would work with dimensional analysis. Mr. Willis, that is way too much trouble. Ain't nobody got time for that, because we just know that 5 minutes is 60 seconds. Thank you. That is wonderful. I'm, again, very proud of you. However, what if, instead of doing 5 minutes into 60 seconds, what if I did, okay, what if I did, let's see, 15.7 years? What if I have a student who is 15.7 years old, and I would like to know how many seconds that student has been alive? Okay? All right, well, do you happen to know the conversion factor for years to seconds? No, me neither. Hey, so what we're going to do is we're going to put 15.7 years right up here. And I'm going to um, put my, oh, look, there's a nice neat bar. And I'm going to put that in there. Now, I'm trying to get to seconds, so what I'm going to do is I'm just going to work to gradually smaller and smaller units of time using using units that I know. And I happen to know that 1 year is equal to 365 days. Now that's the unit conversion we're going to use. It's actually 365.25, but we're just going to stick with 365 for convenience. Ms. Willis, why didn't you put 12 months there? Because a month is a non-standard unit. Some have 31 days, some have 30 days, some only have 28 days. And so we need to go with something that's a standard unit, and 1 year to 365 days is a standard amount. All right, again, I put days on top because I needed my years to be underneath so that my years will cancel in just a moment. So if you want to kind of cancel as you go, you can, and you can see that my years are going to divide away, and then I will be left with days. Okay, so let's, all right, now we happen to know that 1 day, and again I'm going to put the days underneath so that it will cancel, is equivalent to 24 hours. All right, and so I'm going to then get rid of my days. And so now we're down to hours, but I'm trying to get down to seconds, okay? And so let's just continue our march. We're now trying to get rid of hours, so let's put hours on the bottom. I know that 1 hour is equal to 60 minutes. And so my hours will go away, and then I'll be down to minutes. And let's just keep switching colors because that's always entertaining. And now I'm down to minutes, so I need to put 1 minute. And I'm going to get rid of my minutes. Oh, what's that equivalent to? That's right, 60 seconds. Ooh, and so now I have finally made it to my goal. So what I'm going to do is I'm going to do the multiplication all the way across. 15.7 times 365 times 24. Go ahead and do this on your calculator as we're going. Times 60 times 60. Good. And then, of course, we still have to do our division, but since we're dividing by 1 times 1 times 1 times 1, I can do that math in my head and say, hey, that's going to be 1. So I'm going to do that division and know that what I've got on the top is actually going to be my final value. I don't have my calculator with me, so I'm going to let you do the math, and it will be right there for you, and it will be that number of seconds that our 15.7-year-old student has been around on the earth. All right, I hope that was helpful for you. Just a quick introduction to the metric system and dimensional analysis. I'm going to let you do some practice problems on a page that you have there in class or in your Google Classroom, and we'll see you again later. Have a wonderful afternoon.